Good morning, class. Today we'll be having a problem solving activity, right? This is in connection to our lesson in Science 8, which is the laws of motion by Newton. By the way, let me share to you, let me clarify first, your project for this quarter, okay? Right? Remember that we will have an exhibit this 29th, right? The deadline for our project is this 27th. So let me share my screen. Okay. In your LMS, you can actually see there, Project 101, the learning resource material. We are always talking about the learning resource material when it comes to project. Why? Because again, the main objective for this project is to, number one, develop a creative thinking skill. Number two, develop a deep logical understanding of the lesson. Okay. Number three, create a learning resource material based on a science concept. Number four, build a sense of resourcefulness and sense of responsibility because you'll be submitting this on time. Number five, create the quality output to be exhibited by the school because again, this 29th will have an exhibit. Number six, we have fully understand the discussed science concept. Right, let me check on the instructions. The instruction I had given there is create a learning resource material out of our topic, the laws of motion by Newton, illustrating the science concepts that we had discussed. This include but not limited to, number one, 3D of the science concept, diorama, miniatures of the science concepts, the actual science concept, if possible. Okay, make it as attractive as possible. Okay, with your own creativity and any materials of your choice. Okay, this output will be exhibited this 29th. So that is why the deadline is this September 27. All right. Am I making this clear?
Yes.
Okay.
Yes.
Right. Let's have now the problem. Okay. I have here a problem. Let's disregard the previous problem because there is a mistake in the given there. So we need to focus on, or we need to move forward with with another problem. So this is the problem. Can you see my shared screen now?
Yes.
Okay. A
Yes.
constant net force of 200 Newton is exerted to accelerate a cart from rests, okay, to a velocity of 40 meters per second in 10 seconds. Okay. What is the mass of the cart? So they ask there, what is being asked in the problem there is the mass. Okay. We need to look for the mass. Right? So I already given you the formula there. Okay, the formula for acceleration, we just previously discussed this one in your lower years, is acceleration is equal to final velocity minus initial velocity over time, and your external net force is equal to mass times acceleration. Okay, since mass is actually asked there, okay, you need to create formula, you need to transcribe a formula out of this. This is your base formula, right? Okay, I'll give you around 15 minutes to answer this one, and we will answer this all together. All right? I want everybody to share their answers. Okay? Time
Okay.
starts now. Right? Some of you has answers already. So let's answer. Are you all done?
I'm done.
Okay, how about others?
I think I'm close.
Okay, almost. All right, let's continue. I'm sorry for the sudden um disappearance in your screen. Okay, so let's take a look at this example. Okay, a constant net force of 200 newton is exerted to accelerate a cart. Okay, you actually have 200 newton. You're actually pushing a cart from rest. If it is from rest, so the initial velocity there is zero because it is from rest, correct? If from rest, of 40 meters per second, okay, in 10 seconds. So let's take a look at the given there. Given. Okay, let's take a look at if your answers are correct. What are the given? Okay, can you name the given there based on the problem? Given.
Final velocity is 40.
Okay, VF is, okay, wait, right? VF is equal to, what is the VF here?
40
40 centavos?
meters per second squared
40 meters per second. Wait, it is 40 meters per second. Okay,
without a squared.
what else?
Initial velocity is 0.
Initial velocity is 0. What else?
Time is 10 seconds.
T is equal to 10 seconds. What else? What else?
Newton.
Okay, that is your external net force, correct? Is that the
Yes.
external net force? Correct? Which is how many Newton?
200.
200 Newton. Okay. Let's solve. Okay. First, we need to get the acceleration simply because the formula of finding in net force is equal to mass over acceleration, correct? Right. But before anything else, we have already the formula for the external net force, but the net force there is already given. What should we do next?
Acceleration.
Huh? What should we do next? We need to derive formula in order to what? To get the amount or the value of mass. How can we derive a formula out of this? What are the derivatives there? What are the derivatives?
What? The what?
What are the derivatives? We need to derive formula out of this. This is the base formula, correct? In order
Yes.
for us, okay, in order for us to know the value of mass or m, we need first to derive a formula out of this base formula. Correct? How can we derive the base formula here? Okay, we can always use what?
Mass equals force divided by acceleration.
Mass is equal to,
Force divided by the acceleration.
how did you derive with the formula? How you come up with the formula? Always put this in mind. You can always what? Cancel. So we will let, okay, everybody, okay, since we need we need mass here, okay, we will what?
Just switch the places of the mass and the force.
Switch places.
Yeah, I
You mean
just
you transfer it here,
yeah, we just transfer it.
and then
I don't know.
okay, we can actually use this one. So if you want to isolate mass here, we can always divide. Like for example, in this case, we will divide both quantities with acceleration. Okay. Divide them with both quantities with acceleration. Sure. Why do we need to divide them with acceleration? Because we want to eliminate acceleration, correct? Am I correct?
Yes.
Okay. So by doing so, we can actually eliminate or cancel acceleration. Okay. So acceleration now can be cancelled. So acceleration can be cancelled then. So our formula is, in this case, we have mass is equal to F net force. Am I correct? Yes, still
Yes.
following. F
Yes.
net force or net force over what?
Acceleration.
Over acceleration. So this is now our formula. This is actually came from the base formula because we're looking at a mass. Okay. So we have now the formula for mass. Now we need to what? We need to get first or solve for the value of acceleration. So what is the formula of acceleration then? Acceleration is equal to this one.
Final velocity times the initial velocity over time.
Huh? What is the formula of acceleration again?
Final velocity.
Acceleration is equal to final velocity minus initial velocity over time. So what is our final velocity there? What is the final velocity?
40.
40. Do not forget again the units. Okay? Do not forget the units used. Minus the initial velocity. Initial velocity.
0.
0. Okay? The initial velocity there is 0. So, A is equal to divided by what is time?
10.
10. Okay, let's solve. A is equal to 40. Do not forget again the units. 40 meters per second. 40 meters per second divided by 10. What is the answer? 40 meters per second divided by 10?
4. 4
Huh?
meters per second squared.
4 meters per second squared. Why squared? Why
I don't
squared?
know.
Because you have actually one here, one unit here, and another unit here. So this is squared. So your acceleration now is equal to 4 meters per second squared. So we can now actually use this formula since we already have the value of A, correct? Okay, let's have this
Yes.
formula. Okay, mass is equal to F net or your external net force. What is your external net force?
200
200
Newton.
pesos. 200
Yes.
Newton
100
divided
pesos.
by
4 meters per second.
your acceleration
4 meters.
4
4 meters per
Second squared.
second squared. Correct. Okay. Right? So solve. Your mass is equal to
50 kilograms.
200 divided by 4. We have 50, 50, 50 kilograms. Sure, why kilograms? Okay. What is 1 Newton equivalent to? It is equivalent to kilogram per meter per second squared. Are you still with me?
Yes.
We did discuss this one, correct?
Yes.
Okay, so we can actually cancel this. The meters per second squared. Correct? Correct?
Yes.
Yes, sir.
Okay, so your answer is 50 kilograms. That's the mass of the object. So to answer this problem, a constant force of 200 Newton is exerted to accelerate a cart from rest to a velocity of 40 meters per second in 10 seconds. What is the mass of the cart? Okay, the mass of the cart is 50 kilograms. Right? Did this answer the problem?
Yes.
Yeah.
Yes.
Did you get the correct answer?
Yes.
No.
Chavez gets the correct answer. Also, let me have RJ. How did you get with the answer, RJ? How you come up with the answer?
I did what you did.
That's great. So I like that approach. So hopefully you will also be reminded of the formula that we had discussed in your previous years. Remember that this is a continuation of your lesson because this is spiraling. But the formula there, the variables there, the constant variables there are the same all throughout. Okay, whether what concept is that? A pi will always be 3.14, the same all throughout. Okay? Newton will always be equal to kilograms per meters per second squared all throughout. It will not change because it is constant. Do you have any questions so far?
No.
No.
Okay. Let's have an example by next meeting, another example. And please do prepare also for some activities. I am actually looking at an activity that I can actually give to you. Okay, this is more on how can actually solve a particular problem with Newton's law of motion. Newton's laws of motion. Okay, hopefully we can create also a learning resource material out of these 3 laws of motion by Newton. Okay, do you have questions so far?
None.
Okay, I
No.
think that will be all for today, class. Let's have another example by next meeting. Thank you and have a nice day, grade 8. Take care. Bye-bye. Enjoy the rest of the day.
Bye.
Bye.